Hey, hi. Good afternoon, good evening, and good morning, wherever you're based out of. And thank you for joining this webinar on big data engineering for machine learning. I am your host today, Nagesh Reddy, Senior Solution Architect at Kibol. And again, thank you very much for joining in. Just give us probably a minute for everybody to join in, and then we can get started. Okay, so let's get started. So as we in today's world, I think we are hearing a lot about machine learning and AI, specifically the artificial intelligence. Yeah, and machine learning is just part of the overall journey. We'll talk about what machine learning is, basically what it is, what the basic principles, fundamentals of, and then we will see how Kibol actually helps you kind of to get those machine learning use cases implemented. Yeah, and when you're doing it with Kibol, what's the advantages that you have with Kibol? Okay, so if I get moving, so what is that you will learn in today's webinar? Yeah, there are three things that we have highlighted here. One is basically what are the frameworks, engines that are available to you to run your machine learning workloads. So one of the things that we have is basically with all these. So when we talk about, so taking one step back, when we talk about machine learning, we talk about a lot of data. Yeah, a lot of data comes into play. You need a lot of historical data, let's say, to historical data, real-time data, to make sure that you can make sense of. You can create those models which are not biased, which are something which have got good accuracy. Okay, those kind of things. So you need a lot of data. So there are two things that comes into play automatically. One is basically the storage part of it, and the second is basically what kind of modules or engines you can use from a processing perspective. And here we have something called as Apache Hadoop, which is a de facto for distributed storage, and then Spark, Apache Spark from a processing engine. So Kibol provides you both of them. Of course, Apache Hadoop is just a library, and the data storage can be anything like a GCS or a GCS for in Google, or basically S3 or Azure Blob Storage. Any of those can be used. But again, these are something which are the bedrock, or basically the founding principles for big data storage and the processing. And then Spark, being not only from a processing perspective, it can actually take care real-time streaming as well as the machine learning. It can take care of both of them. Then moving on to the next one, basically, what's the modern methodologies and the cloud evolutions? Yeah. So now, if you as you see more and more, you see ops being heard a lot. Correct? You see DevOps. You heard about other ops. Okay. Similarly, now things have evolved, and you can hear a lot about data ops and MLOps. Yeah. We'll talk about those in the next few slides. But data ops are something which is data operation from start to end. How do you gather the data? How do you kind of make sure your data is something which is of quality? You validate your data, you process your data, and so on and so forth. Yeah, and it's basically operationalizing that end to end, making sure there is a minimal human intervention. Automation is involved in that. So, and similarly in ML ops, where you can actually train the data, frequently train it, frequently update your models, and then kind of finally deploy it as and when it is required. It could be a nightly, a weekly, or something like that. Yeah. So there's a lot of operations DataOps and MLOps that you see nowadays in terms of improvements. Yeah. And finally, whenever we talk about big data and machine learning, one of the things that comes into play is the costs actually run us pretty fast, and you have to kind of make sure that okay, you work within your budgets, and this is where kind of FinOps come into play, where you have to make sure that you are cost effective when you are dealing with your big data and machine learning from it. Okay, moving on. Sorry, just give me a second. So before we dwell into the deep dive or kind of deep dive into the other aspects, I just want to give a brief on what Cubol is. Some facts about Cubol. One is we are a data platform, and it's based on open source. It's created by open source platforms and all these the founding people basically. Yeah, something who came from the open source development like the Hive and other engines basically. So we are pretty much open source. All the engines that we have, all the processing engines that we have are open source based. Market adoption, we have pretty broad base, diverse industries. We have pretty much in all the domains. We are based on all the domains, be it financials, manufacturing, pharma, and something like any of those domains you pick up, it would be there. And locations, we have pretty much throughout the world, APAC, definitely the North America and South America, uh, and similarly other regions. Yeah, we're pretty much across. Now, I was talking about FinOps. Yeah, one of the things that we have done is basically FinOps comes keeping in mind that customer is the priority. Yeah, of course we do want to may save a lot of money for the customers. Yeah, and that is what we have been doing uh, from the day we started. Yeah, and that's one of the things. So we have saved almost like 600 odd million, and I think this is just keeps growing every day, cumulatively since 2011. Yeah, and that's a big number. Proven tested, we have exabyte of data being processed monthly, and that's a big number that's been processed. And we have a big customer base who process a large set of data. Presence, we are 24/7. We are loved by customers. The reason is we are 24/7. We have a very good support, and that's one of the reasons customers are with us. Employee, we have a strong tech team. We are driven by good tech, and we have wealth of experience in kind of implementing these big data use cases. Now, who uses Cubol? Yeah, that's the first thing. We have a platform. We call it a data platform, but who this data platform is useful for? Now, Cubol is something which is useful across the organization. Doesn't matter who it is. If he is dealing with data, definitely he can be on Cubol. Yeah, it's a self-service platform where anybody like a data engineer, a data scientist, who are these two primarily being hardcore engineers, they can use Cubol. The business executives who just are interested in their dashboards, they can be on Cubol, and the data analysts and the business users, basically who can write, let's say, a simple SQL queries, they can be on the Cubol platform, writing their queries with our various engines that we have got. I'll talk about that when we talk about the architecture. But yeah, anybody can come in on Cubol, and we have got tools for each one of those personas basically. So it's something which can be used across organization, whoever is dealing with data. Now, since we are talking about machine learning in this webinar, I would like to kind of talk about some fundamentals about machine learning, what it involves. So any machine learning process that you see has got 3 steps. Yeah, the first is basically where you prepare the data. When you are saying preparing a data, you kind of collect the data, you process it, you kind of probably you can do your ETL to kind of transform the data, move it into a format which can be used, or kind of work on the quality of the data and other aspects. Yeah. Then you build and train. Basically, this is where you kind of use your model, let's say a classification, a regression, any of these kind of machine learning models, machine learning problems that you might have, you will kind of build and train in this aspect over here. And the third one is finally basically is where you will deploy it, correct? you will deploy and monitor. So you will deploy it, so you need a place where it can be deployed and can be continuously monitored. And this process is kind of a life cycle where you kind of, just give me a second. Sorry for that interruption. So basically, yeah, the final one is basically deploy and monitor, where you will deploy it and monitor. What does Cubol provide? Yeah, so Cubol does provide you things like when you are talking about preparing the data, end-to-end visibility, how the data kind of lands into Cubol platform, and then uh, finally it goes to kind of, when it is processed, you have got that end-to-end visibility. Yeah. Second, we have automation. We have infra completely taken over. Kind of we let the user kind of just concentrate on their business use case rather than kind of focusing on the infra part of it. Yeah. Flexibility and extension, I'll talk about those in the next few slides, but we can cater to a lot of external libraries, engines, and various other things, which actually helps you in making sure you can prepare your data much faster and better. Build and train, again, rapid prototyping, because you're not worried about how the infra would be managed, the cost overruns and other things. You have rapid prototyping, flawless execution, and then again, I spoke about that before, but a broad support for the ML ecosystem. And from deploying and monitoring perspective, we have again tools which help you in terms of monitoring things, uh, from our dashboards. Second is you can collaborate with our notebooks and other tools that we have. So you can write your machine learning models, build your models, and then it can be shared across your team. So you can collaborate with our Cubol platform. Now, talking about data preparation with Cubol, yeah, I was just talking about the features. Okay, how does it help? One is basically it gives you fill visibility into an entire data pipeline that is start to end. You can. Second is basically you have got various tools to explore, query, and visualize, specifically through Cubol's SQL workbench, where you can any data science or any machine learning use case, you have to first make sure that you can analyze the data, see what are the parameters that you should be using, what are the features you can be using. So you need a lot of preparation for that, and definitely this helps over there. And then we have got integration with JDBC, ODBC, if you want any of the visualization rather than using a workbench. If you want to use visualization tool, you can use that with our JDBC, ODBC connectors. And then we have a very streamlined process of handling different, or let's say diverse data, because assuming that the data comes from various data sources, we have got Apache Spark to get the data and kind of store it, or basically directly ingesting it to and cloud-based storage like S3 or GCS. So it's pretty much streamlined, where we can handle a lot of diverse set of data. It could be a structured or unstructured, either of them. Now, automation and flexibility, basically that's one of the core feature when you are talking about data science, because data science or basically ML is all about exploration. Yeah, you have to explore, you have to do a decent R&D before you come to a conclusion that, okay, this is the algorithm that would actually, this is what will fit into my use case. Yeah, and that's where we help. The first and foremost thing is basically automated data ingestion pipelines. You have got schedulers to make sure that you have all these, as I was talking about in the previous slide now as well, that you can ingest the data from various data sources, be it real time, be it batch, any of those. Cubol takes care of it. Then I was talking about the tools. We got various tools like, I'll talk about them in the next few slides, but you can use Spark ML, but you can at the same time use like TensorFlow, or you can use something else as well. So it has got various support to a large set of engines, basically, yeah, on which you can run your models. Sorry, build your models. Different programming languages you can use basically Python, you can use Scala, you can build your Java code and then kind of execute You can write your simple SQL. You can write execute on R as well. So you have got various programs. So you have got the choice. And as I was talking about earlier as well, uh, anybody uh, uh, anybody from a data science data engineer can come onto CUBOL and start using it. In the same way, it doesn't matter which language it is, correct, or which programming language it is, you can still work on use CUBOL. Enhance productivity and collaborative capabilities for and basically, since the infra is automated, a lot of things are kind of taken care in terms of productivity and collaboration. uh, I was talking about rapid prototyping because machine learning is all about trying out different things, yeah. And how CUBOL actually helps you over there. Basically, it has. I spoke about that, like workbench and other things. So you have got a graphical user interface where you can do a lot of prototyping. Uh, that's one. Second is it has basically engines like Hadoop, Spark, and Prestos, which are kind of which help you in kind of doing it faster, yeah, because the engines are something which are built to process the data faster. And I was talking about the FinOps basically. I'll talk about that in the next few slides as well. But these are something which are automated, yeah, which is built in. So you need not worry about the infra side of it and what would be the end cost of it, correct? And that's something which is inbuilt. So you can do that. Then you have various other machine learning libraries like Spark, Spark MLlib, MXNet, TensorFlow. I already spoke about, but there are a few others that we support like Keras, Scikit, Python and R. Definitely be the core libraries which might be available in Python and R. Now, deployment and monitor was the last piece. Yeah, we spoke about how prototyping, data preparation. Then second is what are the libraries which are available for machine learning, and then finally we come to the deployment and monitoring. Correct. So you can deploy seamlessly, use your trained models using our CUBOL notebooks onto dashboards. I will quickly show that on the demos. Then you can monitor them. You can schedule it via, let's say, workflows, using our workflows, which is nothing but Airflow. Yeah, you can schedule your jobs and other aspects using Airflow, and you can visualize them on CUBOL platform. And I was talking about Airflow, which is basically one of the, if you see in today's industry, everybody is talking about Airflow from a scheduling perspective, considering its flexibility with the language it provides and the ease of use. So everybody is trying to use it. And it's not only in big data and Hadoop, but it is used across. Now, I spoke about these things. I'm just kind of summarizing here what are the technologies that is used across industry, but also in the same things are used in CUBOL as well. But things like Apache Hadoop and Hive, these are something which are again used from massive ETL perspective, doing massive ETL jobs. Again, Hive probably more from, let's say, a batch processing, or writing a simple SQL queries which are more ANSI based, ANSI SQL based, so you can use those. Then Apache Spark. Apache Spark has pretty much taken the entire ETL process or data processing world by storm. Yeah? It can do in-memory processing. It is really fast. It can do both your real-time analytics as well as your machine learning. Then Apache Airflow, it can create your DAGs. It can create a very complex workflows uh, and kind of schedule the jobs. Yeah. And finally, the Presto and Trino, the de facto data warehouse, at least in CUBOL. But yeah, there are a number of open source versions and other companies which are kind of using Presto and Trino from a data warehousing perspective to make sure that you have a fast and interactive query executions. I spoke about these at the uh, start of the webinar, yeah, where we are talking about the various what is that is emerging after the from 2020 kind of the pandemic years, correct? So things are becoming agile, yeah, and that's what data ops and ML ops and basically any operations, you as you try to kind of automate it, you kind of start maturing, you start optimizing thing and operate, making sure that it is automated, correct? And that's what data ops and ML ops is all about. Yeah? You start making sure everything is optimized and automated, and that's where kind of even Kibol comes into play. Then AutoML is one feature that has started changing the landscape, and there are a couple of vendors who are kind of doing that, where you can kind of feed the data. It can suggest you what could be the features which can be used for your machine learning, and then it can also suggest you based on the type of the outcome that you need, the algorithms that can be used. And create a model out of it. So there's pretty much a lot of things that is going in AutoML at this moment to make sure that it is uh, you need not kind of spend a lot of time in preparing those models as well. Now, if you go a few years back, okay, so things were there in cloud, but machine learning and data science was still something which are more on premise, like the buying your GPU servers, working on those GPU servers. Now, if you have seen after pandemic, I think there's specifically after the last year, the OpenAI and other things that came into picture, most of the things have started moving to the cloud pretty rapidly. Yeah, all the heavy use cases from a GPU and other perspective have started moving. Now, what are the trends? Yeah, and what are the migration trends, and but why it is happening? Yeah, again, the same principles that was applicable to cloud uh, for non-machine learning or non-data science, the same principles applies here, where it is we are talking about scalability, the flexibility, and the cost savings that you get when you migrate towards cloud. Yeah? And what are the various platforms that are available to you for machine learning? We have the hyperscalers like AWS, the GCP, and the Azure, correct? So and Kibol supports pretty much on all of them. So hyperscalers are something which are investing pretty heavily on these. Yeah. Now, I spoke about machine learning a lot, and one of the things that comes into play is basically making sure that the data that you're working on is having a proper data quality. Yeah, and if your quality of the data is not good, then obviously your models or the data analytics that you build on top of it doesn't make sense. Yeah. And how does actually machine learning helps in the quality of the data itself, correct? It helps you by detecting the data issues before they have occurred, in the sense that as your data passes through various ETL processes or real-time processing, you can actually make sure that your data quality, you can check your data quality. You can auto-address your data quality issues. That is, you can find those issues and you can fix them where they occur, rather than at the source itself, rather than something which might happen at a later stage of time. With all this, you reduce a lot of manual efforts and kind of start improving, automating things, automating the data quality workloads with using machine learning. Yeah, and then of course your data, as I was saying, that any of your data analytics or your machine learning, you have to make sure your data, you have a reliable data. Yeah? And that's what you will get with this. So as I was saying, machine learning, data quality is essential to machine learning, but machine learning itself is helping to make sure that the quality of the data is good. Yeah, so it goes both ways. Now, when we started, we spoke about FinOps. Yeah. Now, FinOps is all about making sure that you do things, one is faster, and it should not be expensive. Yeah? But since machine learning is something which is based out of big data, and then of course machine learning which has to run on the higher processing units, the CPUs and the GPUs, it becomes very expensive and pretty fast. Yeah. But what FinOps does is basically it makes sure that your performance is not sacrificed. Second is your cloud spend is safeguarded, and then you should not have your basically overspends, correct? You might actually run algorithms and probably you might forget to switch off and various other things. I'm just giving you a few examples, but there might be accidental overspends. Okay, so FinOps is all about making sure that you have control over those. And at the same time, while controlling the cost, you want your basically the machine learning or the data scientists to explore, kind of explore the unknowns basically, and that can be only done if you have proper controls over the finance. Now, how does actually Cubol, what is the Cubol's approach towards FinOps? Yeah. So what it helps is basically it gives you better cloud visibility. It offers tools to make sure that you have better comprehensive visibility on cloud costs. You have detail level tracking. Let's say if you're running a model, if you have a job which is training the training your model, it will give a clear visibility on what the cost is involved over there. Resource optimization, basically it makes sure that it has better resource allocation. It makes sure that whatever type of instances that you need, let's say a GPU based instance or something similar, you use those instances rather than something which might not be efficient from a machine learning perspective. Again, cost forecasting and budgeting is something which is built in, which makes sure that okay, all these analytics will help you in terms of forecasting what is your cost, and you can budget accordingly. Then one of the core features of Cubol is basically it's auto scaling, that is scale up and scale down, and at the same time using spot instances, which are available at way lower cost than on-demand instances in case of AWS, and similarly in case of Azure and other hyperscalers. Yeah, so it has got patented all these the spot effective uses of spot instances. So it definitely helps you in terms of lowering your cost. And finally, your reporting, basically, which you can customize your reports, your cost reports and other aspects to make sure that you, based on that, you make a decision rather than something on without a database. So you can make a data-driven decisions using Cubol's tools. Now, we are talking about what's basically what was before and what is the future, right? And this is where kind of past meets the present. Yeah, the founding principles of 2020 is something before 2020, that is before pandemic years. Yeah, it is still available, but what is happening now is it's ML is becoming kind of embedded into any application that you are using, any small, let's say a web application, mobile app, whatever you pick up, you might have ML in that. And now it is going beyond with this all the craze on basically the AI side of it. So and things are possible because you are able to you are getting those processing power at lesser cost, and tools like Cubol helping you in making sure that you can run it at a decent cost rather than burning your fingers. And this is about is this a thought before we jump onto the demo. And the new possibilities in ML, and with basically advanced data engineering techniques and expanding rapidly, as I was talking in the before slide. Yeah, and it's important to first understand what are the fundamental principles of it, and making sure that as we move on, we leverage those fundamental principles for the new use cases across multiple industries. And as I said, Cubol is at the forefront, kind of helping the different domains or different industries which are there, and who wants to kind of excel in this machine learning journey. Just to recap, as we spoke about, all these DataOps and MLOps are something which are making sure that you evolve faster. That is, you do your data prototyping or ML prototyping much faster with these DataOps and MLOps, and definitely it is the tools like Spark which are enabling them. What are innovative trends, of course, DataOps and MLOps we spoke about, but something which is coming up is FinOps, which is focusing on financials to make sure that all these innovation are something which are cost bound. And then future of ML application, and that's something which is we just spoke about, this unlimited, and with this new AI craze coming in, it becomes even far-reaching. Before we jump into the Cubol demo, I just quickly would like to give you a intro on the Cubol architecture. Yeah, Cubol has got 3 layers per se. It has got the middle part in this diagram architecture. If you see, it is called as Cubol control plane. The left side is something which is called as Cubol data plane, and the right side is the consumption. Cubol control plane, that is what I would show you today in the demo, where you have all these nice tools to manage, using which you can build your machine learning models, train your models, deploy your models, and other stuff. While the left side is something which is your cloud environment, we make sure that data is something which is in your cloud, resides in your cloud, to make sure that we have data security, because in machine learning, data security becomes very paramount. You have these the computers on your VPC part, in your VPC in your cloud, and then data is also pretty much in your data lake. Yeah. And consumption, we spoke about the various like ODBC, JDBC, then we have Java-based and Python-based SDKs, we have APIs, and of course we have the nice Cubol graphical user interface where users can log in and kind of do their operations, yeah, whatever they want to kind of do. So this is a high-level architecture. I'll quickly switch on to the demo. So I've already logged into Cubol. Here in this case, it's us.cubol.com, but we have something for India, which is Asia Pacific. That's basically in.cubol.com. And then you can connect to any of the AWS region. It's not limited to a specific India region, but you can connect to any of those regions. Similarly, you have EU, which is Europe. Now, I'll quickly talk about Cubol here. The various tools that are available you have, and one of the things I was talking about is the various personas who can come onto Cubol and use this as a self-service tool. Correct. So you have tools like Explore, Analyze, Workbench, and others which are more simple query-based tools, so that anybody can come in and do the job. Then we have notebooks, which are the powerhouse. Basically of Cubol, you basically a data engineer who wants to write a complete ETL, they can do it. You have Jupyter notebooks. I think that's a de facto tool used by data scientists or a data engineer nowadays to get your work done. Yeah, that's something which is available. Then you have dashboards. I think we spoke about that, where your machine learning jobs can be scheduled onto dashboards. You can do that. We have pipelines, again, to make sure that your data pipelines are real-time data pipelines can be automated. And we have schedulers. These are inbuilt schedulers, where if you have simple cron jobs, you can do that. But we have, as I spoke about, we have Airflow. I'll just show that in the clusters. Then you have clusters where you can use your various processing engines. This is the usage I was talking about, the FinOps, where you can actually track all your usage, and it can go to the level of job. Control planner, where you can do all the settings. Environments is something where you can install all your Python libraries, the machine learning libraries, and other aspects which you can install using environments. And there are other controls that you have on the from a platform perspective. Quickly jumping onto clusters, I'll show you 2 aspects. One is basically what are the processing engines that are available, and how, and basically how, from a data science or ML perspective, what are the 2, how you can use a notebook. So from a engines and tools perspective, we have Hadoop, basically Hadoop Hive. Then you have got Presto, Spark Streaming, Spark both Spark Streaming and Spark. We spoke about MLOps, yeah. So MLflow comes into play here, and then Airflow again from MLOps. If you want to kind of automate, schedule it, you can definitely use Airflow here. So these are the various engines. I'll quickly show you how it is configured, just for quick 1 minute over here, where you can select the various versions of Spark. Basically, all the Spark-based ML libraries comes by default. Then you can use the various type of nodes that you want. You can use the minimum or maximum worker nodes to make sure that you can auto scale based on the workload that you might have. You can select the region, you can select the availability zones, and then you can upscale your EBS volumes as well. Yeah, you can use the different EBS volumes, and you can upscale your EBS in case you're running out of the storage. Yeah, and over here, if you see, it's basically your usage of spot instances that I spoke about, mostly from a FinOps perspective. You can use on demand or spot instance, a combination of both, or just a spot instances from a auto scaling perspective, where minimum nodes can be on demands. You can decide what could be a spot instances percentage, because again, the spot instances are something which can be um, retrieved, or kind of preempted any point of time by AWS when there is a requirement of that node. So you can set those a percentage of spot nodes as well. As we move advanced, you can configure which VPC you want, which subnet you want, and any other custom EC2 tags to make sure that you can control your cost and other aspects. You can override a lot of Hadoop and Spark configurations as and when required, and the same goes to Presto. And in Presto, you have advantage in terms of using caching as well. So you can set up all these Spark, use all these Spark settings. You can use which Python version, which R version to be used, and stuff like that. So this is about how to set up a cluster. It's easy. As I said, a lot of infrastructure part is kind of taken over by Kibol, and the users, the data scientists and data engineering can concentrate more on their business use case, building the models rather than on seeing how they can efficiently use the infra. Now, jumping on to notebooks, as I said, notebooks are something which are powerhouse in case of Kibol. So let me take you to examples, and here you have a bunch of machine learning. You have a data scientist workflow. You can, and you have deep learning, where you can actually see if you I have a couple of examples which are basically in ImageNet, Keras. So you have a lot of stuff here which are related to deep learning as well. Now I'll quickly show you customer churn. This is one of the ML use case that I have here. It's load in a few seconds while it does. So this is one for the customer churn. This is a solution architecture where you have the source data files, and then you have this Spark, which is used for ingesting the data. At the same time, it is doing the refining and curation and basically features and labels and other stuff, which is pure Spark, correct? And then Spark ML takes over, where it does this hypothesis testing with chi-square test, and then splits the data between your train and test. Other activities are done by ML. Yeah. And then it actually, since this is a customer churn, will it churn or not? This is most of a classification example. It does, and it does use multiple algorithms to see that, okay, which one actually fits better from a deployment perspective. Right? So you execute all of them, and then finally you select a model and then fine tune it at the end of it. Yeah. So this is the flow, this is the architecture basically, and this notebook actually contains this entire piece. That is the full architecture implemented in this notebook. Yeah, you have all these from right from data sourcing to basically over here where the model is created, and then of course you can use Airflow for, in terms of deployment, or you can simply go and deploy from a notebook. I'll show you how to do that. But yeah, as I scroll down, you see this is a data ingestion. Basically, you are reading the data from S3. Then this is just This is display of the data. Then you have data curation, and all this is written in Spark. And since you are using notebooks, you can use Spark, Python, or whatever, wherever you want to switch based on that, you can switch. This is a initializing machine learning pipeline, feature engineering, and machine learning again pipeline. Yeah, so as you see it, I'll just scroll down to the end of it. You will be able to kind of see all this. Finally, the model selection and tuning per se. So as I was saying, notebooks are something which are powerhouse and it can do a lot of stuff in COBOL. Yeah. So this is notebooks for you. And finally, I'd like to show you a quick on Workbench. So this is the Workbench where we spoke about where anybody can come in and write their queries. Yeah, and this is a simple SQL query. It will show you all the Hive clusters on which you can run the job, but you can create a new collection. Pretty much go to, let's say, Spark, and when you go to Spark, you can write you have all these bunch of options. You have Scala, you have Python, you have R, you have command line, and you have SQL. So you have all these options. So as I was saying, as a data scientist, you're spoiled with options with the different programming language that you have available over here. That's one. One more thing I would like to show you from a data science perspective is, or machine learning perspective is, let me jump to my preferences. And if you go here in environments, yeah, this is a very cool feature where you have to install these various packages. And what we have observed as a data scientist or a machine learning engineer is how do we kind of manage all these packages, or as we install, how to make sure that these doesn't clash. That is one, and second is basically it fits into the environment that we are executing in, correct? So that's kind of abstracted in case of COBOL. You can go ahead and add any packages using Conda or pipeline. You can install any of these, yeah. Using simple advanced, you can add your package name, basically the version, and then off you go. And then you can select the cluster here, whichever cluster you want, it will go ahead and install over there. So I'll stop over there. Take a pause for a few minutes, and then let me see if I can answer a few of the queries from the attendees. Okay, so one of the query that I have is basically, can you integrate with external tools? The answer is yes. We can integrate with external tools and I think I was talking in the slides as well, but you will be able to integrate with external tools like S2 OAI or something similar to that. Any of the third party, you will be able to kind of integrate. And I have another similar question, basically, can you run TensorFlow? Yes, we can. And as I was going through the notebooks, I was actually showing you on the menu side that we had some Keras and deep learning based examples. Yeah. So yes, we can. Okay, let's give a minute more. Okay, one of the questions I think this is pretty common that is being asked is basically what is the pricing model of COBOL? Yeah. COBOL pricing model is something which is pay as you go. It's basically the type of the instances and number of instances for the duration that you use. Yeah. That's what you will get charged on. You just do a Google search on COBOL pricing on AWS or GCP, you will get those pricing. So it's mostly pay as you go, and it's the resources that you would be using on the cloud side of it. Okay, thanks everybody for joining in today, and hope this was an informative session for you. Thanks everybody. Thank you.